let's try to solve another Leetcode problem. 1953, maximum number of weeks for which you can work. So let's just try to understand the problem. So there are n projects numbered from 0 to n minus 1. So 0 to n minus 1, it means just the index of the milestone. So we are giving an integer array milestones, where milestones I denotes the number of milestones the ith project has. Yeah, so for example, milestones 0, it means there's gonna be one project, and milestones 1, it has 2 projects, and milestones 2 has 3 projects. Now we're gonna work on the projects according to the following rules. So the first rule is that every week you will finish exactly one milestone of one project. So this means in 1 week we can only finish one project. So for example, for this milestones 2, it has 3 projects, but for each week we can only finish one project. Yeah, and you cannot work on 2 milestones from the same project for 2 consecutive weeks. But for the next time, we cannot work for this milestones because we've already worked for it. So next time maybe it is another one. It is this one. Yeah. So for example, the first one will be how can I make it? Yeah. So maybe for the first week it's gonna be milestones 2, and this is for milestones index 2, and for the second week it may be milestones 1 index 1. It's gonna be another project. Yeah, and then it may be 2 and 1 index 1, and then milestones 2 for one project, and milestones 0 for the last project. So in total there are going to be 6 projects. So this is what we are doing. So this one just means there are going to be a project. So this is just the index 2, index 1, index 2, index 1, index 2, index 0. Yeah. So we're going to return the maximum number of weeks you would be able to work on the projects without violating the rules mentioned above. So if we cannot finish all of the milestones, all of the projects, so we're gonna stop it. So inside the second example, we cannot finish all of them. So in total, we can only finish 7 projects. So we're gonna return 7 instead of 8. Yeah. Actually, this is a greedy problem. We just need to find a formula about how to calculate it. So let's just say S gonna be the sum of the milestones, and the maximum gonna be the max of the milestones. So what's gonna be the formula like? Yeah. So if we have the maximum of the milestones, it must have some relation with others. Yeah. So what left behind? So just imagine we have the maximum of milestones inside of this array. It's gonna be 3. So what left behind is S minus mx. There must be some relationship between this maximum and the total sum minus the maximum. Yeah. So if they are equal, so it is okay. Definitely we can finish. So this means something, if they are equal, we have AAA, and we have BB, and C. So the maximum is 3, and the total is 6 minus 3, it is 3. So something like AAA, BBC, definitely we can make it work. So it's gonna be something like AB, AB, and AC. So for the first example, yeah. But what if we have more A's? We have 4A. This is also works because for the final one we can still have another A. Yeah. So this means the formula is gonna be like, even this equals to S minus mx plus 1, it will still work. Yeah. It also works, but this gonna be the maximum number we can have. Yeah. So this means if a number which is more than this number, S minus mx plus 1, if a number is more than this number, definitely it didn't work. So inside of the second example, 5 is more than 8 minus 5 plus 1. 5 is more than 8 minus 5 plus 1 in this example. 5 is more than 4, definitely it didn't work. So this means for this number, instead of 5, it has to be another number. It's going to be this number, S minus mx plus 1, which is going to be 4. S is going to be 8, minus mx going to be 5. 8 minus 5 plus 1, it's going to be 4. This means instead of 5, we have to use a 4. So 4 plus 2 plus 1 going to be 7, going to be the final answer. If we can find this kind of a formula, definitely we already know how to solve the problem. Yeah. So this means if a number is bigger than this one, so instead of using that bigger number, we have to use this number. And then we're going to use this number to plus other numbers. So what left behind is s minus mx. Yeah, so this is going to be the final return. So the condition is that if mx is more than this one. Yeah, so otherwise we just need to return the s. S is the total sum of the milestones. Yeah, so let me just get to the final return, and after that let's just prove why it has to be this kind of formula. Yeah, why it works. So it's going to be this one going to be 2 times, so this formula going to be 2 times mx plus 1 2 times s minus mx plus 1 if the condition is like that. Let me just copy the formula. Otherwise it's going to be s. Yeah, so let me just run it first to check if it works. Yeah, now as you can see it works, and let me just submit it. Yeah, as you can see it passed for all testing cases, and it's pretty fast, and the time complexity is just O(n). N is the length of the milestone, so it is 10 to the power of 5. That is why it works. Now let's just prove why it has to be on this kind of formula. Yeah, so this one, s minus mx plus 1, we have to prove s minus mx plus 1 gonna, even we reduce this number, it's gonna always be the biggest number, and it always be the unique number. Yeah, we have to prove 2 things. One thing, it has to be the biggest number, maximum number. It has to be the maximum number, and secondly, it has to be unique, the only one number. Yeah, otherwise, why we gonna only reduce this one? Maybe other numbers is bigger than this one. So yeah, first of all, we're gonna prove this one must be the maximum number. So let's just use some examples like 5, 3, 1. So this 5 has to be the maximum number. It cannot have something like 5, 5, and 1. Because if we have something like 5, 5, 1, and 1, definitely it works. Yeah, because mx is gonna be smaller and equal to s minus mx plus 1. Definitely it works. So this means even we have the maximum number, if it didn't work, this maximum number has to be a unique number. Yeah, and also it is exactly the maximum number. We cannot have something like 5, 5, and 1. Yeah, because this 5 and this 5, definitely it can consume all the possible cases already consumed, and for others definitely it works. Yeah, so yeah, normally we needed to prove this one, this maximum number. Definitely it is the maximum number because we are choosing the maximum number, and secondly this must be a unique number. Even we reduce this number to 4, and this 4 has to be the maximum number, and this 4 has to be the unique number, and 4 plus 2, I think this is a 2, so 4 plus 2 plus 1 gonna be 7, gonna be the final answer. Yeah, because the total sum inside this example, 5 to 1, it is 8. Yeah, so if we reduce this number, yeah, if we reduce this number 5 to be 4, so we reduce the 1, so the total sum gonna be 7. Yeah, but this 4 must be the maximum number because 4 is more than, yeah, because 4 is more than 7 divided by 2. Here we're gonna choose the floor of 7 divided by 2. 4 is more than that, so definitely even reduce this number, it has to be the maximum number. It has to be the unique number. It cannot have another 4 because 4 plus 4 is going to be 8. It's going to be more than 7. So this is why we have to use this formula, and it's going to always work. I think that's all about it. Thanks for watching. See you next time.